Right. Let me also record this session. The recording is also started. Streaming and recording started already. So today's agenda is to discuss about conjoint analysis. So this is one of the important topics for your exam point of view. And so in the last class, I talked about predictive and prescriptive analytics. So what is prescriptive analytics? I'm sure you all know predictive analytics. What is prescriptive analytics? What is prescriptive?
Advising some.
Yeah,
changes.
you are making some recommendations. So let's say you are going to make a new product. Make a new product or build a new product. So what do you know? What do you have to do in order to build a new product?
We have the previous model data.
Yeah. So from all the previous data, you're trying to find the ideal product. You're trying to find the ideal product, and you also compare your product, your current product with this ideal product, and see how far you are from the ideal product. Right? And this is as far as conjoint is concerned. When you think about DEA, what does DEA do? It tells you which business units are efficient and which business units are inefficient. And if you want to make an inefficient business unit into efficient, what you have to do? What recommendations does DEA give?
Drag to the nearest efficient, like project.
Efficiency friend.
Sorry, can you repeat?
Basically, we do the something like for the inefficient product, we make some changes in the product,
Okay.
like either input or output, to make it also an efficiency frontier.
Yes. So you have output
We should push it
by
on to
input.
frontier.
So if you want to, if you want to make an inefficient unit efficient, you either have to reduce the input or increase the output. So how much of input you have to reduce? How much of output you have to increase? So all these things, these recommendations are given by DEA. So again, I'm repeating this course. It started with simple statistics and visualization. Then it went on to some statistical tools like what is that? I'm not able to. So two categorical, you're trying to find the association between two categorical variables and so on. And then it went on to simple linear regression, multiple linear regression, and logistic regression. All these things are predictive models. And the last two models are prescriptive models, DEA and conjoint analysis. So now coming back to conjoint. So what does conjoint analysis mean? Why is it called conjoint analysis?
Pairwise comparison.
Okay.
We are looking for all the features together.
Yes, we are not looking at any feature in silos. Rather, we are looking all the features jointly. So that's why this name conjoint analysis has been given. So we are trying to understand the customer's thinking process in buying a product. So we collect data from consumers. So what types of data do we collect? Two types of data typically have been discussed in this course. One is pairwise comparison. So what does this mean? The customer prefers 1 over 2. Right? The other kind of data is, what is it?
Rating comparison.
Rating. So higher the rating, better it is. So when you are given pairwise data, what method you will use for doing the conjoint?
Linear regression.
Linear regression or optimization. approach you will take. But whereas if you have ratings, what approach you will do?
Regression.
Yeah, statistical approach or regression approach.
So pairwise is not for linear regression?
No, rating is for regression. Pairwise you use it for optimization model. All right. So before getting into the nuances of pairwise statistical model and so on, so we have to make certain things clear. So in the last 2-3 batches, many people were afraid of this linear programming formulations, especially in conjoint and DEA. So as far as the final exam is concerned, we are not going to trouble you by asking you to formulate some problems, giving you the objective function, give you some results and analyze the results and so on. So that is not fair, because the idea of business analytics course is to introduce these concepts. We are introducing conjoint and DEA. In fact, we did not give you any assignments on DEA. We did not give you any assignments on conjoint, and asking you to formulate all these things in the exam is not fair. But what we look for in the exam is your understanding. So when do you use conjoint? When do you use in conjoint? When do you use pairwise data? When do you use statistical approach and so on? Where similarly in DEA, so why are you using DEA? And how do you make recommendations and so on? We want to understand your understanding on conjoint and DEA. That's all. So don't complicate it much. Just understand how conjoint works and so on. So that's all we expect you in the exam point of view, right? So what are the 2 important questions that conjoint is going to answer?
Find the ideal product and
Yeah.
weights of attributes.
Okay. Yeah, that is pretty much correct. The first thing is how much each attribute is important to a customer. Rather, we are trying to find the weights associated with each attribute. That is the first question that we are answering. Then we are trying to find, you mentioned coordinates of an ideal product, right?
Yes, sir.
Okay, so rather than saying coordinates of an ideal product, you can say what are the values of an ideal product, because coordinates we do it in pairwise. In rating, in statistical approach, we don't find the coordinates. If you recollect, we are not finding coordinates for a regression model, right? We do something else. We calculate park worth and so on. We'll discuss all those things. So ideally, conjoint is answering 2 important questions. One is, what is the weights associated with each attribute? And if there is an ideal product, what are the values of it? All right. And what all we can talk about conjoint analysis? What are the different types of conjoint analysis? So it starts with choice-based. What is choice-based?
Basically, consumer is given a few number of products to choose from.
Yeah, exactly. So it's also called, you are given a full product, right? You are given a full product and consumer is asked to choose which product is of interest to him. For example, let us say a consumer is given a Tata car and a Hyundai car and Maruti car. So he has to decide Tata or Hyundai or Maruti. It's a full product. There is no engine, just one attribute like engine from Tata, gearbox from Hyundai and so on. It's a full product. So customer has to say, I want Tata, right? So based on this choice, you will be able to understand something. So what can you understand if consumer is choosing Tata? Can you guess? Can you make a wild guess? Why consumers go for Tata?
Safety.
Yes, exactly. So if a consumer is choosing Tata, it means he is more interested in safety. What about Hyundai? If somebody chooses Hyundai, why should he choose Hyundai?
Luxury look.
Looks, features, sunroof, ventilated seats, and all those things. What about Maruti? If somebody is choosing Maruti, why do they go for Maruti?
Price.
Price, okay. What is it?
Low maintenance.
Oh, mileage,
Service.
fuel efficiency.
Sir, after
data hai.
after sales
Yeah,
service. Sir.
Yes, service. These two. So based on the consumer's choice of the product, you can understand what is influencing his or her decision and so on. Right? So the next thing we'll talk about is adaptive conjoint. Second thing is, what is adaptive conjoint? So your questions will change dynamically. For example, you are interested in understanding a customer's requirement for a car. So the moment the customer says, well, I want an automatic car, right? Your next question will be based on the previous question. So the moment you know the customer wants an automatic transmission, you will have questions that will depend upon this automatic car. For example, sunroof. So you may not ask this question because most of the automatic cars will have a sunroof by default, right? You don't have to necessarily ask a customer, do you need sunroof? The moment he says, I need an automatic transmission, sunroof comes default with an automatic transmission. You don't have to ask this question necessarily. And based on the answer to the previous question, your next questions will change and so on. So that's adaptive conjoint. What about full profile? So that's what
Basic cars are given.
that is what sir has taught sir has taught for 2 weeks. Whatever sir has taught for 2 weeks, it's about full profile, where you are given multiple products, right? 1, 2, 3, 4, and there are variants, right? So customer has to either rate or give pairwise comparisons, right? This is full profile. What about the last type that sir has introduced? Menu based. What is menu based?
Consumer is given about the full value of the attributes what he wants.
Okay.
On the basis of that, he chooses the product that for this attribute I choose this, and for this that attribute I choose this, and combining all that attribute we make a product.
Can customize.
Okay,
Sir.
so partially correct. It's almost
for each attribute, what is the price?
No. It is slightly different. You are almost there. So let's say the customer is given $100, right? So for this $100, customer can choose either seat covers, right, or air purifier, right, or something like a subwoofer, music system that amplifies the sound quality. So $100, which attribute does customer prefer more? Some customers who travel longer will prefer seat covers, right? Some people who are hygiene sensitive, they will prefer air purifier. Some people, especially the millennials, the young people, they prefer this woofer to hear loud music. So based on this particular money that let's say there's a fixed amount of $100, right? Which attribute is more cozy to the customer, right? Which he prefers, seat covers or air purifier or subwoofer for the given money. So similarly, you can keep you can understand which attribute is more significant for a customer through this menu-based analysis and so on, right? What else we have got? All right. So the next thing comes the optimization approach.
Sir,
Yes.
so the difference between full profile and choice based is that the choices are limited in choice, right?
No.
All the choices are given.
Might be here you are given a full product. So Tata, we don't give you engine separately, we don't give you gearbox separately, steering separately, and so on. It's a full product, choice based. Tata, Hyundai, and Maruti. So out of the whole product, customer has to decide one. Maybe he's not buying this, but you are asking for which product would you prefer more?
Sir,
Right?
in
I
full
asked
profile
you. In full profile, what you have is you have different variants, right? Maybe consumer likes Honda's engine more than Maruti's engine. Consumer might like the features of Hyundai over Honda and so on, right? You have variants and different products. You are looking at different attributes in a full profile. Here, choice based, you are only given a full product. There is no separate engine transmission. It is there, but you are only comparing the full products. That is the difference.
Okay, sir. So in full profile, we are seeing the attributes.
Yes, in full, it's called, the names are maybe slightly confusing. Here, you have variants. And for each variant, you are giving a rating. You have products and you have variants. And for each product, for a particular attribute, you are giving rating. May you like Honda engine more, you like features of Hyundai more, and so on. Maybe you don't like the features of Maruti, you will give a lower rating here. Right? So by doing this, you are going to find the ideal product. And you are going to find the weights associated. That's all. And we are going to look at full profile conjoint analysis. Right? So this is slightly, the optimization approach is slightly difficult. So be with me here. We'll see what is what. So whenever you have an optimization problem, what all is required here? What is the first thing you will see in a linear programming problem?
Objective function.
Yes.
Objective.
What is the objective function here?
To maximize the to maximize the efficiency, like
That is
maximizing
for
the
DA.
output and normalizing the
Yes.
input.
The answer is correct if I had asked the objective function of DEA, but this is conjoint optimization. So here we want to minimize the, what is it called?
Poorness of fit.
What is poorness of it? What is poorness of it?
Deviation from ideal choice, sir.
Yes.
Yes. Yes. Amazing. Amazing, sir. What is your name?
Vijay Kumar.
Vijay Kumar. Very nice, sir. Which means you fully watched the video carefully. Thanks for making my job easy, sir. So let's say
Yes, sir.
1,2. What does this mean? Consumer prefers 1/2. Right?
So,
Then-
which choice I am doing here? Is it CBC, adaptive conjoint? Which one I am doing here?
Full profile.
Okay.
Full profile conjoint analysis. So let's say, if I say 1/2 and 2/3. So ideally, 1 should be over 3, right? Is it fine? 1/2, 2/3, which means 1 is preferred over 3. But what if I mistakenly say I prefer 3/1? What is this? This is a violation. Although my mind says 1 is preferred over 3, by mistake, because you are asking me too many questions, so I tend to make mistakes. What if I say by mistake that 3 is preferred over 1? This is a violation. You are wrongly giving an information, and in the optimization, we are trying to minimize these violations. Even though you give a wrong entry, you wrongly say that I prefer 3/1. That is being accounted. It's okay. I am allowing some wrong choices to be recorded, but I will minimize this violation. It's also called poorness of fit. And what is this objective function here? We say minimize Sj minus Sk plus, what is this?
Maximum of 0, Sj minus Sk.
Yeah.
Correct.
So why do we have Sj here? It should have been dj minus dk, right?
Sj squared.
Yeah. So what is this dj first of all?
The distance from the ideal.
Yeah. Distance from the ideal product. So how do you measure distance from ideal product? So let's say you have an ideal product that is here, and your particular product is somewhere here, right? So this particular distance, right? So how do you calculate this distance? What formula do you use to calculate distance?
Euclidean.
Euclideans.
Okay,
Weighted
Euclidean distance. What is the formula of Euclidean distance?
Square. Coordinate square.
So it is, let's say you have x1, x2, and so on. Euclidean distance formula is something like this. So x2 minus x1 the whole square plus y2 minus y1 the whole square. So isn't so if you are asking to minimize the distance, is it going to be linear? I don't think so. We are not going to have a linear objective function since it is under root. So what you do? You take the square of this. You take the square of this. You know x2 and x1. So let's say x2 is 7 and x1 is 3. So 4 squared is 16. Similarly, this is something like 5 minus 2. So 2 square is 4. So 16 plus 4 is 20. So now is this linear? Is this 20 linear?
Yes.
So that is what you are doing. So you are converting a non-linear problem into a linear problem by squaring the Euclidean distance. That's all. That's all this objective function is doing. You are trying to minimize the violations. That's all. And what are the constraints that you might have? What are the constraints? So if a consumer is preferring J, the distance is always lesser than K. So let's say there are two products. Let's say K and J. Let's say there are two variants, K and J. If J is preferred over K, the distance of J from the ideal product is always lesser than SK. This is one constraint, right? What is the other constraints? Constraint the weights, right? The weights should be greater than or equal to 0, right? And so on and so forth. This is all. This is all you need to know about pairwise conjoint full profile analysis, right? You have an objective function. What is the data type that you have? You have pairwise data. You have an objective function that is minimizing the poorness of it. And you have a non-linear objective function. You are linearizing this objective function by squaring it. Then you have a simple constraint. There are two products, two attributes, K and J. And if J is preferred over K, this distance should be lesser than SK. That's all. The weight should be greater than or equal to 0. That's all. And how did you linearize the objective function in DEA? Do you remember?
Normalizing
So in DEA,
denominator.
yeah, in DEA, you are maximizing the efficiency, output by input. So the moment you have a ratio, output by input, it becomes non-linear. So what did you do? You maximized the numerator. And you gave a constraint that output by input should be less than or equal to 1. So this in turn, if you cross multiply this here, output should be less than or equal to input. So this is how you linearize the objective function of DEA. So similarly, you have an objective function and you are linearizing it here.
So,
So
sir,
next we go. Yeah.
so one thing is said here repeatedly that this function, this attributes value should be continuous for the linear programming. Why it is like that?
Yeah, it's a good question. You need a formal training on that. So it is continuous because generally you want to maximize something your answers might be in something like 19.76 and so on, 76321 and so on. It is going to be like this. Whereas if you say how many people are required to do a particular job, so this is a discrete variable. So you cannot have 19.2 people. It doesn't make any sense. So for solving this kind of problem, you don't do linear programming. You do something called integer programming.
Okay.
Right? So in linear programming, generally the objective function, everything is linear and it is a continuous variable. That is what we assume and go ahead. So you cannot round this off. You cannot round 19.2 to 19. If you do this, your answer is not optimal.
Okay. So, sir,
therefore,
my question is that actually my question is that for the linear programming approach, I can give the attributes values in categorically, that 1, 2, 3, 4, 5, 6 you can give. Then why this problem will not be, linear programming will not be preferred then?
No. Here, linear programming. All right. So we again go back here. So you can complicate this as much as you want. Here in linear programming approach, we are taking pairwise data. 1 is preferred over 2, or 2 is preferred over 3. 1 is preferred over 3. So if you have this kind of data, you use linear programming approach. That's all. But if you have ratings, let's say we'll look at ratings shortly. We have a separate Excel exercise for that. So is linear programming okay so far?
Yes, sir. It is very clear. You very clearly told us.
Okay. So the next thing is statistical approach.
So
what about statistics?
Poorness of fit for all data points, right? We have to minimize poorness of fit.
Yes.
For all the data points.
Yes. For all the pairwise comparisons, not data points. You be more specific here. You say for all the pairwise comparisons. Okay.
Yes, sir.
So we collect data in the form of ratings, and here generally, if you use a regression, what do you estimate in regression?
It is also it is also for full profile.
Yes, this is also for full profile. In regression, what do you estimate?
So, sir, just a minute, because it is very much complicated if I read it first time. So, what I am asking, can you put in values here? Like I take the 2, 1, 1, 2, 3 and attribute 1, 2, 3. Now, what is the difference is happening? Why when you go for statistical and when you go for linear programming?
So, there are two approaches. The most commonly used approach is statistical approach, right? Okay. So if you want, it depends on the data you are collecting. Let us say you have an educated audience, right? So they can answer questions more clearly. So they know what their product should look like. For example, a customer knows that he wants a 1.5 liter engine, and he knows what a 1.5 liter engine is capable of. And let's say there is a gearbox. There are 3 different types of gearbox. There is a torque converter, there is a CVT transmission, there is an AMT transmission. Okay. So if the customer is able to clearly say, well, I prefer torque converter over AMT gearbox. So if he is very knowledgeable, you collect data in pairwise method.
Okay.
And customers should have that willingness to do that. It is going to take a long time. You are going to ask each and every question. So for gearboxes, which is more preferred? For a touch screen, do you prefer long ones or tall ones? Do you prefer thin ones? So it's a tedious approach. Whereas statistical approach is very clear. So you just rate. So if it is a 10-inch touchscreen, the customer might give 9 out of 10 as rating. If it is a 7-inch touchscreen, he might give 6 out of 10 as ratings. So it is very simple statistical approach.
Okay. Okay. Very good. Yeah.
All right. So we have regression. And what do you estimate in a regression? What is the null hypothesis of regression?
Factors are independent, sir, of result.
those are some kind of assumptions. But if I have, let's say, an independent variable and a dependent variable, so let's say 2 independent variables and 1 dependent variable, what do you estimate? When you build a regression model, what are you finding out?
Finding out y, sir, dependent variable.
You are modeling, you are trying to find y hat. And how do you find y hat?
Weights and the intercept basically.
Yes. You are estimating betas, beta naught, beta 1, beta
Yes,
2, and so on. So you are trying to estimate these parameters, right? So in this regression approach, these betas are called part worth. What is part worth? These are also called level utilities. Another name given to them is level utility. These are concepts borrowed from economics. That is, utility value of separate part of the product. It is relative part worth. What is the utility of that level of attribute? Right? It might be slightly overwhelming, but we'll see this in a regression. So this is the data that sir has used. I'm using the same data. So let us look at this shortly. Right? So there are different manufacturers. So they have a battery, front camera, preferences, and so on. This is how the customers are giving rating. Right? If they see 4,500 battery and 20 megapixel, they are giving a rating of 7. If they see a lower camera, the rating is going down. If they see a higher camera, their rating is going up. If they see a higher battery, the rating goes up. Right? They are giving ratings. So 1 being the least and 10 being the highest. You look at the highest rating, high camera and high battery. So there are 3 manufacturers, Samsung, Vivo, and Xiaomi. There are 2 batteries, 4,500 milliampere hour and 6,000. There are 3 combinations, 20, 13, and 8. 3 cameras.
Sir,
right? Yeah.
So each row is corresponding to one single phone, right? Product.
Yes, yes. This is a particular variant of Samsung. This is a variant. This is a different variant. Each row is unique here.
So in full profile also we look at all the options, right? All the different mobiles available.
Yes, yes. But you are also looking at attributes separately. In choice based, you don't get to see all these things. You have, of course, customers are given, battery, front camera, manufacturer, and so on. But ultimately, the decision they have made is Samsung here. We have not looked choice-based in detail here. So therefore, don't confuse choice-based with full profile. In full profile, you are getting into details of the attributes. What is the worth of this particular battery? So what if I do, if I upgrade my battery to from 4,500 to 6,000? What is my part worth? How much my part worth is increasing? So all these things we see in full profile. All right. So I am coding this data. So Samsung, what type of variable is this?
Categorical.
Categorical. So when you see categorical, you can code this data, right? So manufacturer Samsung is 1, Xiaomi is 2, and what is the other variable? Xiaomi and Vivo is 2. Vivo is 2 and Xiaomi is 3. 4,500 battery is 1 and 6,000 battery is 2 and so on. So camera, as far as camera is concerned, 20 is 20, 13 and 8. 20 megapixel is 1 or 8 megapixel is 1, 13 megapixel is 2, 20 megapixel is 3 and so on. Right? I am coding this data. What is the next thing I am doing? What is sir doing here?
One hot encoding.
One hot encoding. So Samsung, look at this. So this particular option is, if it is 1 here, then the other 2 brands are 0 here, which means that this particular brand is Samsung, right? So this particular row corresponds to Samsung only. It is not Vivo, it is not Xiaomi. Similarly, this particular row, it is Vivo. It is not Samsung, it is not Xiaomi, right? So this is one hot encoding. And if you're not aware of this one hot encoding, please ask your friends and please revise concepts from MLF and so on, right? And similarly here, 4500 battery, if this is 1, it means 6000 will have 0 coding. So we are encoding these attributes. So what about this? Camera, front camera?
If one is 1, another 2 is 0.
Yes. So if this is 1, the other 2 are going to be 0. If this is 1, these 2 are going to be 0, right? So this is one hot encoding. All right. So this is variable definition. Final coding. So what is happening here? So we had removed, we have removed Samsung here. We have removed 4500 battery here. We have removed 8 megapixel camera battery here. What are we doing here?
Basically, we are removing the multicolority of the variables because two are defining the other variable.
What is your name, sir?
Abhineet.
Abhineet. Very good, very good. Can you also tell me what is multicollinearity?
There is
Effect
a
of
relation
okay,
between two independent variables.
Yes, yes, you're correct. For example, here in this context, if you know Vivo is 0, Xiaomi is 0, and it obviously has to be Samsung. If these two are 0, you know that it has to be Samsung. If you know these two values, you can automatically understand what the other value is going to be for Samsung. Similarly, you know it is 1 here. So Vivo is 1 here. So Xiaomi and Samsung are going to be 0. You don't have to have that extra information, which is going to cause some errors in your computation due to multicollinearity, right? So here, this is battery column. If you know this is 0, 6000 battery is 0, it means that it is 4500 milliampere battery. For that row, you are going to have a 1. Right? These are simple multicolor one-hot encoding concepts. We are not going into the detail. I think you are getting it, what I'm telling you. If you don't understand, I can repeat this. Right? So you are creating this particular data set from the customer rating. Then what is happening? The usual thing, the regression thing, you go to data, you give the target variable. What is our target variable?
Preference.
Rating preference.
Yes, the ratings are the target variable and these are the inputs. All right. So how many inputs we have? We have 5 inputs. Vivo, Xiaomi, 6000 battery, 20 megapixel, 30 megapixel. So these are the input features. So from this, we are calculating multiple R square, adjusted R square. What is multiple R?
The correlation between the multiple independent variable?
Square of correlation coefficient.
No. So this is your preference. So next you have preference predicted, right? This is actual. Then by regression, you build a model and you predict something. So this could be 7.2, this could be 3.9, this could be say 0.9 and so on, right? You are predicting something through regression. Am I correct? And if you look at the correlation between your actual and predicted, you get multiple R.
Oh, I don't know. Okay.
Okay. All right. Then you have R square. You know what is an R square?
Yes.
You know adjusted R square, right? And you know these things, these typical things that we covered in our multiple linear regression and so on. So what is important to us? Whenever you see a regression diagnostic, regression statistics, what do you see first? You see the coefficients. What is the next thing that you have to see?
Standard error.
No, not standard error. Our most important thing, p-value. You check whether this variable is significant or not. Are the variables significant? Is the p-value less than 0.05 significance level?
Yes, sir. Variables are very much significant.
Yes, all the variables are significant, right? So now next what we do, what is part worth here? Can you compute the part worth here?
Sir?
Yes.
So do we need to know the formula for computing T statistic and F statistic also?
No, sir. No, I don't know, so I won't ask you all those things. So here we are going to get into calculation of part work. So here we have two batteries, 4500 milliampere hour and 6000 milliampere hour. So you have 8 megapixel, 13 megapixel, 20 megapixel. And here Samsung. Why did we make 8 megapixel as 0? So this means that we removed this particular column. We could have removed 30 megapixel, right? So here if you see, right, sir removed this particular column called Samsung. I'm hiding this. And sir removed this 4500 milliampere hour. And sir removed this 8 megapixel column. So instead, sir could have removed Xiaomi. Instead of Samsung, he could have removed Xiaomi. He could have removed 6000 milliampere battery. He could have removed 20 megapixel camera. What is the reason behind sir making Samsung as 0, 4500 battery as 0, 8 megapixel as 0? Can someone tell me?
It is getting a less rating as compared to other.
Yes. So according to this sample data that we have created, Samsung was the least rated mobile. And if you look at the battery, this is the smallest battery possible. Here, 8 megapixel camera, this is the smallest camera possible, right? And these are the values of your betas. Let's go to beta. What is the value for 6000 battery? 2.33. 6000 battery, it is 2.33. Next, what is the value for 20 megapixel camera, the beta associated with it? It is 4.834, right? So now what I'm having Samsung, Vivo, Xiaomi, and I'm having the respective betas for them computed through linear regression, right? So next, what do we do? From this, what do we do?
Sir. Sir, also if we had made Vivo as 0, then the rating for the beta value for Samsung will be negative, right?
Yes, it's a very, very interesting question. I would ask you to try that. It need not be negative. It could be. Just check it out. That was the next thing that I was planning to say. Try doing that and check for the answers. Right? It's like a ungraded assignment for you. Make Vivo 0 and have Samsung and Xiaomi. Look at the betas for them. It could go to negative. It could be negative. Okay. So the next thing we are going to do is calculate the range associated. What is range? What is the range for this? If you look at the brand, you have the minimum value is 0, maximum value is 1.834. What is the range?
1.834, sir.
For brand, it is maximum.
Samsung.
Yeah. So maximum minus minimum. Yes. If you do this, you are going to get 1.834. Right? This is the. Okay, I didn't. What did I do? I did not. Okay, I got it. It's going to be the same. All right, let's a second. So now if you add everything, so now if you divide 1.84 divided by this, what are you going to get?
weights of the attribute.
Yes. What does that say?
How much important is that attribute?
Yeah. So let's convert this into percentage. So it says camera is the most important attribute, followed by battery. Brand is of no use. I mean, it is the least important attribute for a customer's buying decision. And more importantly, what does this tell you? 4,500 to 2.334. If a customer gets an upgrade from 4,500 battery to 6,000 milliampere hour battery, his worth goes by, his part worth increases by 2.334. Similarly, if a customer is upgrading from 8 megapixel to 13 megapixel, his part worth increases by 2.167. From 8 to 20, it goes by 4.834. Right? So these are also called part worth. This is what we discussed previously. What is part worth?
The
It is
beta's value or utilities value.
utility and a level of an attribute. Utility for a particular level of an attribute. For battery, what is the part worth? For camera, what is the part worth, and so on. So now, did you intuitively understand this? So that's all. Conjoint is all about part worth and pairwise comparisons and so on and so forth.
So if we don't make the value 0, then can we do regression for Samsung and 4500?
You will have that multicollinearity problem, right? You will get an answer, but is that answer correct? How do you know whatever? See, right now regression is giving you some result. It is giving you beta naught, it is giving you beta 1, and so on. How do you know that beta 1s are correct or not? If you don't make that 0 thing, if you don't remove that particular variable, say Samsung, you don't remove 4500 battery, you don't remove 8 megapixel camera, you are going to get results, but it may not be correct. It will have multicollinearity problem. You will have double countings here and there, and you are going to get a lesser R square. You're going to get a lesser multiple R. You're going to get a lesser adjusted R square.
Yes, sir. And the beta won't be significant. Like it may be 0 also.
Sometimes, yes. Sometimes, yes. That is also possible.
Sir,
Yes, yes, sir.
what is the value of y beta 0? What is it implies, sir?
Intercept.
Yes, sir. What does it makes for the preference, sir?
That's a very good question. So here, it's like your ideal product should have some. I'm not able to tell you exactly, but here intercept we don't have a proper definition. Yeah, it's a very good question. I can also find and tell you more about this intercept. It is like I'm not able to give you the exact definition, but it does not have a lot of significance here. Generally, you will have if you are doing a house price prediction, right? What is the value of intercept? It is something like a fixed cost. So the minimum amount you have to pay is this much, right? And if you look at this from price elasticity point of view, that is the maximum you can get. That is the market size. Intercept is nothing but the market size. If you are offering product for free, what is the market size? That is the value of the intercept. In this context, you don't have an exact definition for intercept.
Okay, sir. Okay, sir.
Hey, Amita, okay, we'll talk later, Amita, sir. We'll talk after this live session is over.
The intercept also takes care of the factors that are not present in the data, right?
No, it doesn't take care of factors that are not present in the data. Whatever data is present for that, it is making some approximations. So what you are referring to is called a latent variable. So that latent variable thing, maybe to an extent, this intercept can also take care, but those are complicated topics. Let us not have it here.
Sure.
Sir, also the regression, that means the formulation was like slightly difficult for me to understand.
Yes, even for me it is difficult, Prashant. To be frank, even for me, even now after doing this for many years, it is difficult for me. The only way you can get better at this is by practicing. One way is to download the sheets and understand each and every cell in that Excel, and do some real-time projects, get data, try to create data. You know how to create data. You can ask your questions. You can formulate an interesting problem. Let us take IPL. So now IPL is coming, right? Can you build an ideal team through conjoint analysis? You know who is the best opener. You know who is the best fast bowler, right? Can you build an ideal team through conjoint analysis and check how far is Mumbai Indians from the ideal team? How far is Chennai Super Kings from the ideal team? Right? The only way to get better is do some practice, get your hands dirty.
There is some minimization of ZIK and the constraints with beta and alpha values.
Yeah. So that's why I'm telling you, understand the intuition first. So understanding here is poorness. You're trying to minimize the poorness. You're trying to minimize the SJ minus SK. You're trying to minimize the violations and so on. You have constraints. What are the constraints? The weight should not be less than 0. It should be greater than or equal to 0. And SK should always be greater than SJ if J is the preferred choice of the customer. So if you have this intuitive understanding right now, then you can slowly start formulating the problem more. And sir has given 2 research papers. Sir has referred to research papers in this lecture. Try to download those papers and read. And if you get a chance for doing your bachelor projects, bachelor thesis, try to do something in DEA and conjoint. It is you will get good results, quick results. You can also publish these papers and so on.
So, sir, also tell the higher authority that give a BA2 course.
BA2 course, sequel.
After BA1, give us a BA2 course. There is a lot of boring course of system commands and other thing.
Sure. Why don't you write a mail to Professor Rahul saying that you are requesting for BA course 2 and put Bharati madam.
Nobody listen.
Please, he will be very happy to see this email. I'll do one thing. I'll stop the live streaming and then we can have some conversations.
Okay.